So I hope you can hear me. Hello, everyone, and good evening. I'm absolutely thrilled to be here at the DLD conference. It's actually my second time, and this time I brought the exciting mix of an upcoming cold and food poisoning. So I hope that I can make it through the presentation. I'm gonna be here at my little podium, but if I need to run off, you know why. And then I hope you enjoyed the presentation so far. But joke aside, I think the last 2 days have been really full of exciting conversations, really great discussions about highly relevant topics. So what we saw is, for example, conversation about climate change, pandemics, diseases, and really what we're up against in the world. Now, interestingly, what we heard many times, and even some of the speakers say, is we expect science to find solutions for these pressing challenges, for these urgent topics. So now the question is, how often do we actually take a step back and say, how can science actually fulfill these expectations? How can researchers find solutions? And how can AI help with that? So for these two topics, we're going to explore that in the next 50 minutes, and I'm looking forward then to have that conversation with you. Now, starting off with what is actually science, right? Let's start with this topic. Can you imagine a world without antibiotics to fight infections, or without smartphones? It's almost impossible, right? Or can you the tuberculosis vaccine, which saved millions of lives? Or the theory of relativity. I mean, that's something that reshaped physics and enable technologies like GPS or advanced imaging. None of these breakthroughs would actually have been possible without science. For half a millennium, science has now underpinned human progress and rational decision-making. And as Isaac Newton, you see it written here, has said, "If I have seen further, it's by standing on the shoulders of giants." And what that actually means is you can see this in this picture here. What you're looking at is the publication record of our flagship Nature journal, which is the world's most prestigious science journal. And in this thing, every dot which you see here actually represents a paper. And it's building on a paper which was published before, across disciplines, which you see here also in the color coding, and for more than 150 years. So imagine this, it's a snapshot of an ever-growing collaboration and discovery across science. So now if we look at today, the role of science really hasn't diminished. Actually, it's the opposite. It's getting more and more important. Think of COVID-19. Global researchers had to come together when the pandemic hit and really had an extremely fast development of vaccines. Climate modeling. AI-enhanced models help us now to predict and mitigate and adapt to global risk. Or look at protein folding, and this is what you see here. A question that really puzzled scientists for more than 50 years. How do proteins actually fold into the shape that then enable life? And there was a team at Google DeepMind of scientists who actually cracked that nut. And you see this paper, which is published here in also Nature magazine, absolutely groundbreaking and will really enable then new routes for drug discovery. But the challenges our planet now faces today mean that science is more critical than ever. But for science to really do this work and really to push us forward, two things need to be true. The first one, it needs to be trustworthy, so that the findings we see here we can build on and that they are credible. The second one is science needs to be very fast at generating new discoveries. In fact, it needs to be faster than ever before. So the question is, how can we keep science both trustworthy and fast to deliver solutions? And what role can AI play in this? Well, let's take a quick look and let's start with science and think about science trustworthiness and think about what is even the problem here, like why do we need to think about this? Well, let's take a quick look at the information environment we're currently operating in. According to the World Economic Forum Global Risk Report, misinformation and disinformation rank among the most critical short-term global risk. And I think you know this if you go to online, if you go to channels, there's just so much deepfakes, AI slop, in information and news we consume. And some sources even say that if you think about the traffic, 51% are already bots, only 49% humans. So think this is the environment we're currently operating in. Now, this is also becoming increasingly a challenge for science. Generative AI makes it easier now to produce very convincing but fraudulent scientific papers. People can make up fabricated data, fabricated images. So this can come from individuals. Some of them want to boost their career, but there are also large organizations who actually make this a business. So you can actually go to them, and for a fee, they create a fake scientific paper for you. So now, I think all of us would agree, nobody wants to live in a world where we cannot distinguish between real scientific findings and something a software made up. Because imagine if that would be the case, medicine could, for example, not be allowed to be given because of fake research, or the opposite, which would be even worse. Imagine medicine would be approved based on fake research. So that being said, I think this is why science publishers like Springer Natures and others, editors and viewers must really be vigilant about making sure that we preserve the integrity of the scientific record. But good news is, we're not powerless against fake science, actually opposite, and I'm gonna show you how that actually works. So, scientific publisher. First of all, again, we ensure the integrity of the scientific knowledge. Upholding editorial standards, so peer review, and really retracting inaccurate research. Now, how it works in detail, you see actually here on the slide. The image shows how research is filtered through different stages, starting with if you submit a manuscript, automated checks, manuscript screening, editorial assessment, independent peer review, editorial decision, and then it gets published. And to give you an idea overall of the size, we had, and you see it here on the left side, only in 2024, 2.3 million submissions. That means 1 every 10 seconds. And if you think about then all the way it goes through, after a rigorous review, 1/5 of all submissions, roughly the 482K articles, then actually get published. And in between for this review, there's really a gigantic process of people involved in this process, gigantic number, 1 million people. So this is the process of what we're doing here, and this filtering has worked well for a very long time. Now, there is an important trend and a challenge. Because what we see is the submissions here on the left-hand side, they are increasing. They are growing much faster than actually the people who make then the review, who are filtering. So what we need to do is we need to make sure we can still do the filtering, and with that is exactly where then AI actually comes in. So I could talk about many tools that we are using here, but I want to stick to two, also given the shortness of time of the slot. There's actually two. One is the nonsense text detector. So that's something, if something comes in the manuscript, it gets already marked for the editor that this is nonsense text, probably, most likely, AI generated. The second one is irrelevant reference checker. So that shows if there are citations in the paper which either don't make any sense, don't exist, or whatever the reason is. So it also marks in the manuscript for the editor already, this is something you should double check. But that being said, it's still absolutely important. The tool flags potential problems, but the ultimate decision is always with the editor. So let's move on to the second aspect we had, the need for speed. Well, no matter how we look at the climate change or the other topics I mentioned, diseases, food security, We all want solutions, and you want them as fast as possible. That means what we're doing is we're doing everything to accelerate the pace of research. But how would that actually work? Well, if you think about what researchers are doing, many parts of the research cycle are actually quite time-intensive. Writing a paper, submitting it, getting through peer review, then eventually publication, and then the dissemination. So these steps take significant time, and only 45% of all researchers say they have enough time for the core research. So what do we do? And again, the question, how can AI help with this? If you look here across the research cycle, and this is the classical discover, write, submit, review, which I just shared, we can actually help by automating some of these most time-consuming steps. And again, we could have many examples here, but I'm gonna pick two, with the first one being AI summarizes existing research. So this is AI-powered literature overviews, which helps then researchers just to stay abreast with their specific field, because they spend almost up to 30% of their time just looking through researchers, getting the latest information. And that's something where they can have already a solid foundation, what to look for and what the current status is. The second one is AI-assisted writing tools. So that's something helps researcher for a first draft. They can structure the manuscript. It helps with the clarity. But also think about non-native speakers. For them, it takes up to 50% more time just to write the manuscript. But here, they can have help and just produce a much better paper in shorter time. Now, the actual research, I really want to stress, of course, still needs to be done by the researchers themselves. And that's something AI can assist reviewers and save a significant amount of time through the research cycle. And yes, also what I stressed before, but it's still people who need to make the ultimate call. I really want to stress that and say the whole system, all of that this is working, is predicated on actually having highly trained people who can interpret correctly what the AI is proposing. Now, that being said, I want to come to the end and summarize some key takeaways for you. So first of all, if we want to effectively address the challenges of our time, we need to make sure that science is both trustworthy and fast. In the age of AI, we see really this misinformation, disinformation. We really need to safeguard research integrity. Second one is, at the same time, we must do everything to get new reliable research finding out faster, because we're in a race against time. Secondly, AI can help us improve trustworthiness and speed, but it needs to be used responsibly. And again, it's all really predicating on having training and the people who ultimately then work with us in the system. And third, let me end with a broader reflection. Science is not just a tool. It's a foundation of human progress. Today, more than ever, we rely on science to deliver solutions that protect lives, that ensure equity and sustainability. But science cannot do this alone. To unlock this full potential, we need to work together across sectors. That means building bridges between disciplines and industries, between scientists, technologists, policymakers, and publishers. And together we can then combine scientific rigor, technology information, effective policy frameworks to create scalable, trustworthy innovation that actually benefits us all. So with that being said, let's connect. Thank you for your attention, and I look forward to continuing the conversation. Thank you.